Hello students. Today we are going to talk about lesson 7.3 in math, which is called simplifying algebraic expressions. So first off, make sure you have your math journals out and open to a new page. I want you to head the page or title the page, lesson 7.3 notes. You don't need to write the whole title out if you don't want to, but lesson 7.3 notes, so that you have a place to take notes on. Okay, first we're going to talk about some new vocabulary or some new terminology that we need to know for this chapter. And I have them listed over here, and I would like you to go ahead and to write them in your literature journal as well. So you can call it vocab. Sorry, not your literature journal, your math journal. You can call it vocab. The first one we're going to talk about are like terms. Now, like terms just mean that terms that are alike, that are similar to each other, that are that match each other. So you're going to write down like terms, okay? And I'll give you some examples to write down next to it. But a term is made up of, our next vocabulary word here is coefficient. C-O-E-F-F-I-C-I-E-N-T. Coefficient. So a term is made up of a coefficient and a variable, okay? So if we look over here, I've listed some different terms out here. Our coefficient is the number that precedes, that comes before the variable. So this is our coefficient, 3, and Q is our variable. All right, so 3Q is a term. We use these terms in our algebraic expressions. 7a plus 3q. This is made up of two terms. The term 7a, wherein the coefficient, that's your new word, is the 7, and a is the variable, plus our second term, 3q. 3 is our coefficient, q is our variable. And so that's what makes up our algebraic expressions or equations. Okay, now over here I have listed 9 different terms. And we're going to talk about what makes a term like terms, or what two terms are alike. All right, so we have our terms. They're made up of a coefficient and a variable. Let's talk about the coefficient of W here. Does W have a coefficient? Actually, it does. Because what function are we doing when we have 3q? What does that mean to do? It means to multiply, right? 3 times q. So the coefficient of W here is actually 1. And that's something that you have to remember, okay? The coefficient of W is 1. We don't have to write it when we're writing our expressions as simple as possible, because 1 times W is just W. 1 times any number is itself. So we don't have to write this coefficient. But when we get to actually simplifying algebraic expressions, excuse me, we do need to remember that there's a 1 in front of the W. All right, so that is our coefficient, of W there. All right, so we need to find out which terms are alike. One way to think about that is to think that the variable is similar to a label. So if they have the same variable to them, then they are like terms, okay? So let's look up here and find all the like terms for 3q. We have 3q. Now we're gonna go look for any other term that has a q attached to it, attached to its coefficient. So we have q over here. Do you remember what q's coefficient is? It's gonna be 1q, right? So 3q and q are like terms. They're like each other. They're alike because they both have the variable q. And then we have 2q over here. And then we have 1/2 q. And that's also a like term. What is 1/2 q's coefficient? It's 1/2. Now we could be sneaky, and we actually could also write this q over 2. And that would be a like term with 3q. But that's why I wrote it this way, so that you can see it a little bit easier, because it's still just a coefficient and a variable next to each other. But we could simplify it and write it like that as well. All right, let's look at W. We have W. Let's find all the like terms for W. W, and then we have 7W, and then we have negative 4W. So those are all like terms. They're matching. They have the same variable, they have the same label. Finally, we have two more like terms. They don't have any variable to them, but 12 and 8 are also like terms. Okay, so that's not difficult to understand. That's not confusing. It should be pretty straightforward. If they have the same variable, then they are like terms. If they have no variable at all, then they're like terms. But 12 and 7W are not like terms. They don't have the same variable, so they're not like terms. So 8 and 3Q, they're not like terms. If we had 8 and 8Q, those still aren't like terms because they don't have a matching variable. In order to be like terms, they have to have a matching variable. Here's one more variation we could do on like terms. There's lots of variations, but here's another one just for you to think about. We can have more than one variable attached to a coefficient. So we could have 2 mv, right? We have 2 times m times v. It has 2 variables and a coefficient. So we could still have 8 mv, 8 times m times v. These two are like terms because they have the exact same variable. They're matching, okay? Now, we could not have 8 and 8mv. Those are not like terms. They don't have a matching variable. So that's what you're looking for when we're talking about like terms. Do they have matching variables? All right, so we've talked about like terms. They are a coefficient and a variable, and they match another coefficient and variable because the variables are matching. We've talked about the coefficient. The coefficient is the number that precedes the variable. It is what we are multiplying the variable by. And then our last term is simplify. And we've been talking about simplify a lot. You talked about it with simplifying fractions, right? Make them as simple as possible. Get them down as small as possible. And then we've been talking about how to write the algebraic expressions as simply as possible. Okay, that's a term that you're familiar with. We're going to continue to use it now as we simplify really big algebraic expressions down to ones that just have maybe 2 or 3 terms in them. All right, and then we talked about terms as the parts of an algebraic expression. So that's the vocabulary that you need to know as we move into this lesson. I'm going to pause the video so I can erase the board and put up some new information, and I will be right back in a moment. All right, I left the vocabulary up here. Hopefully you have the vocabulary written in your journals right now so that you can reference back to it if you need to. But this is what we're looking at when we're looking at simplifying algebraic expressions. So this is true, right? 4 plus 4 plus 4 is equivalent to, that's our other big word that we're learning right now, equivalent to, it equals, it's the same thing as 4 times 3, right? And we can do that logically. 4 plus 4 is 8 plus 4 is 12, which is the same thing as 4 times 3, right? Or 3 groups of 4 equals 4 times 3 or 3 times 4. Okay, if that's true with a number, that's also true with a variable because a variable stands in for any number in the world. So that means we can say A plus A plus A is equivalent to A times 3, which we simplify or which equals 3A. Now let's try this. Make sure it's true for anything. Let's say that instead of A, let's say A equals 7, right? If A equals 7, 7 plus 7 plus 7 equals 21. 7 plus 7 is 14, plus 7 is 21. So then 7 times 3 equals 21, and this means the same thing. 3 times 7, 3A, equals 21, right? So that's how we can simplify. That's how we use our variables to simplify what we're writing. A plus A plus A takes 5 symbols to write it. That's the same thing as 3A, which is just 2 symbols, right? So do you see how that simplifies what we're doing? It makes it easier, it makes it shorter, it's less numbers to write, fewer symbols to write, and so it simplifies it. That's all we're trying to do when we're simplifying algebraic expressions, is write them in an easier way that takes fewer symbols to write, okay? So then we can do the same thing with our bar models here, right? We said this part of the bar equals y inches, and this part of the bar equals y inches. And so if we want to know how much it equals total, we would say it equals y plus y. Can you think of a way to write that more simply? Y plus y simplified, right? Y plus y is the same thing as 2y. And so it equals 2y inches. Do you see how this is simplified? It's shorter to write, and that's what we're getting at when we want to simplify something. We want to make it shorter to write, okay? So it doesn't mean it's easier to solve. We can do 2 plus 2 in our head and it equals 4. We can also do 2 times 2 in our head and it equals 4. It's not saying that it's easier to solve, but what it's saying is that it's shorter to write. Usually that makes it easier to solve as well, but sometimes it gives us tricky situations. But y plus y equals, or is equivalent to, that's our term, is equivalent to 2y inches. Okay, so that's what we're doing when we're trying to simplify something. And we can do it with all kinds of situations. Again, I'm going to pause, erase the board, and put some new situations up. All right, here is another one. This gives you a triangle, and it says each side is p centimeters. So this is an equilateral triangle because all the sides are the same thing. It has that prefix equi, like equivalent. So it's a triangle where all the sides are the same length. Okay, the perimeter of a triangle, remember a perimeter goes around the outside of it. And so in order to find the perimeter of this triangle, we simply add all 3 sides together, right? So that would get you p plus p plus p. P plus p plus p. Can you think of a simpler way to write that? If I asked you to simplify this expression, how would we simply write p plus p plus p? This is repeated addition, right? And repeated addition is the same thing as multiplication. These are 3 groups of p. So a simpler way to write that is 3p, and then we want to make sure we include our label on here when we're given a label. And so we write 3p centimeters. Just a couple little notes as we're moving into algebra for you to recognize. Sometimes when we're putting a label, especially a shorthand label on something, it can be hard to see the difference between the label and the variable. So you want to make sure you give it a nice good space in there, because when we write variables next to each other, we don't write spaces. They go right next to each other as if they're in the same word. So make sure you put a nice space between your variable and your label. It also can be helpful to use cursive for one and print for the other. Now, other variables that can get confusing are an S, right? And especially if you're not being neat in your work, an S and a 5 can start to look really similar, right? Another one that's confusing is a T and a plus symbol. They really look exactly the same, though the plus symbol should be a little bit smaller. So just if you start to look at it and go, oh, they look the same, I don't know if that's a T or a plus symbol, or Miss Buto might not know if it's a T or a plus symbol, then what you're gonna wanna do is you can write a cursive T, right? Just give it the little loop, and then of course it's a T and not a plus symbol, or a cursive S. You'll notice in your book they often what's called italicize the variables, which means they make them slightly slanted so that it's obvious. Another one that's confusing you saw earlier can be a Q. if you write a Q like this, well, especially on the whiteboard, I have no idea if that's a Q or a 9. Now, obviously in your work, you would probably have a line that goes underneath it, and that would help, but even in your work, sometimes you're messy between a Q and a 9. So it's really helpful to give it that little leg slash, I don't know what you call that piece at the bottom, just to make the difference between a Q and a 9. So just some things to keep in mind as you are starting to work and include letters in your math. It can get a little bit confusing, so it's helpful to use cursive or print or just to be super, super neat so that there's no confusion there. Okay, so we talked about P plus P plus P simplified is 3P centimeters. 3 times P, 3 groups of P. There's our 3 groups, right? So that's how we simplify. And it's really simple, it's really simple to simplify when you have just one term, one like term. It can get a little bit confusing when you have more than one like, or 2 different terms that aren't alike. So this next problem we're gonna do has different terms that aren't all alike, and we will talk about those, how we can pay attention to those and make sure we keep track of all of them. So again, I will pause the video so I can erase and put up a new problem. So on this video, we have what they say are 6 rods that are lined up on the, well, they're not lined up, but they're laid down with their ends touching to each other. We have 1, 2, 3, 4, 5, 6. 6 different rods that are next to each other. And the question asks, what is the length of all 6 rods? Right, so this is just a putting together problem. We lay one piece against each other, and it's just like putting together blocks on your, if you use those connecting blocks that you used in kindergarten, or laying strings together, right? All we need to do is add them to get them together. So let's go through, let's list what we're adding together. And then we need to look at, just like when we write fractions, we always need to check at the end, can we simplify it? Now, when you write algebraic expressions, you always have to check whether or not you can simplify it. So we have Z centimeters plus Z centimeters plus Z centimeters plus Z centimeters plus 2 centimeters plus 5 centimeters. All right, so we have Z plus Z plus Z plus Z plus 2 plus 5. So that's the length of our rod. That sort of answers the question, but we want it in its simplest form possible. So now let's go through and identify all of our like terms. And I'm going to show you how I want you to be doing this. And there's an important piece to it. So when we look at our like terms, we're going to circle the whole term, because sometimes it can be hard to see them because they move around or they're not all next to each other. And so we're going to circle our terms. So we have Z, and do you remember what is the coefficient of Z? Remember, the coefficient is the number that comes before the variable. So what's the coefficient of Z? Well, it's 1, right? And we're not going to write that on every single one, but just keep that in mind because it is there. Now, when we go to this next one, what we're going to do is we're going to circle our like term, but we're going to include the symbol with it, whether it's addition or subtraction. We're going to include that symbol before it, because those go together in a set, plus Z, or plus 1Z. All right, and then we have this one, and we have this one, and then we have a plus 2, and we have a plus 5, okay? So we want to make sure that we circle. It's sort of like it's negative or positive symbol. And when they're all positive, it doesn't seem to be as important. But later on, when they are sometimes positive and sometimes -2, then it gets really important. And that's why we did all last week on adding and subtracting negative numbers and on that commutative property of addition so that we could apply it here. So let's add these together. We have Z plus Z plus Z plus Z. That's going to equal 1, 2, 3, 4, 4Z. So we rewrite it, 4z plus, and as we're adding them, you can go ahead and cross them off, right? We know that we did those. So we marked through our circles so that they are done, they're out of the way, we used them up, we don't need to worry about them anymore. Now, we have two more like terms, right? Plus 2 plus 5, well, 2 plus 5 is just 7. So we get 4z plus 7 here. We're not quite done yet, even though this is as simple as it gets. These are not like terms. 4z and 7 are not like terms. So we can't simply add them and get 11z because it's not 7z, it's just 7. So they're not like terms, so we're not going to add them together. But we need to go back to our question, and our question asked, what is the length of all 6 rods? So a length always needs units with it. And we know our units are centimeters. We were told they were all centimeters. And so we're going to write centimeters at the end. But if we just put centimeters at the end, we talked about this a couple weeks ago. If we just put centimeters at the end, really all that's saying is 7 centimeters, right? So we need to put our parentheses around that whole problem so that the centimeters applies to the 4z and the 7. We add these together and then add the centimeters on at the end, right? So that's how we simplify. Again, it's all addition. They were all in a nice neat row for you. But circling them and crossing them out is a good habit to get into because when they're all mixed up and some of them are subtraction, some of them are addition, sometimes it's multiplication, it starts to get really confusing. So go ahead and circle them and then cross them out. All right, at this point, I would like for you to open up your books to page 231 in your book. And on there is an opportunity for doing the guided practice problems. And I would like for you to go ahead and pause the video and complete problems 1 through 6, and then come back and we will do them together on the board and you can check them, okay? So pause the video right now, complete the problems, and then come back and I will have them on the board for you, ready to go. All right, so the instructions told us to simplify each expression and then state the coefficient of the simplified expression, okay? So number 1 is x plus x plus x plus x plus x. So to simplify these, we have 5 groups of x, and so this simplifies to 5x, right? 5 times x, 5 groups of x, and our coefficient is simply 5, right? It's the number that comes before the variable. Number 2, we have like terms, y and y. So y plus y equals 2y. And then 6 is not a like term. So we can't just say 8y. That wouldn't work. So we would just say we've used this term, we've used this term. So all we're left with is plus 6. And then in here, our coefficient is 2. You're welcome to just underline the 2 as when it asks you what the coefficient is. You can just underline the 2. That's just fine. All right, number 3, we have m plus m plus m, and no more like terms to m. So this equals 3m plus, and then we have like terms plus 5 plus 4, which obviously equals 9. So we get 3m plus 9, and our coefficient is 3. All right, last one. We have like terms n plus n plus n plus n plus n plus n, and that's 6 n's, and no more like terms here. So this equals 6n. And then we have plus 12, which is a like term with minus 8, right? Positive 12 minus 8 is just 12 minus 8. So 12 minus 8 equals 4, and it's a positive 4, so we're going to put plus 4. 6n plus 4, and 6 is our coefficient here. All right, so those are numbers 1 through 4. Number 5 was a perimeter problem, and it says a square has sides of length x centimeters. Find the perimeter of the square in terms of x. Well, again, we know the perimeter is we simply add all the sides together, but if all the sides are the exact same, that's x plus x plus x plus x. So that's 4x, 4 x's that we're adding together, and that equals 4x. Now remember, we're not done with just 4x because we're talking about a length here. And so we have to write 4x centimeters. We have to give it a label. Remember to put that space between your x and the c of your centimeters. Number 6, it says a figure shows a trapezoid. The length of each side given is given as shown. Find the perimeter of the trapezoid in terms of w. Again, perimeter is just adding up the length of the outside. So I'm going to start at the top. We have 10 centimeters plus w plus w plus w. Right, so there's our terms. We have 2 sets of terms in here. We have like terms w, w, and w. W plus w plus w simply equals 3w. And 10, we don't have any terms to combine it with. So 10 plus 3w. And then again, we're centimeters here, but because we want the centimeters to apply to both 3w and the 10, we're going to put it in parentheses. Parentheses centimeters. Okay? All right, that's where we're going to stop today in our simplifying algebraic expressions. Okay, our terms that we learned today, our new vocabulary, are the phrase like terms, which means terms that are matching in their variables. They don't have to be matching in the number that comes before the variable needs to be matching. So like terms. And then coefficients. Coefficients is that number that comes before the variable. So here our coefficient is 3. 10 is not a coefficient. It's not connected to a variable. So it's its own term. This is a coefficient. 3 is a coefficient. And then simplify to make it shorter, to make it easier to write. So those are our major terms for today. Tomorrow we'll get into some more difficult terms, and then we'll be applying your knowledge of adding and subtracting with negative numbers tomorrow as well. So I will see you again tomorrow.